Solid-state batteries, the future of energy storage. A revolutionary leap in battery technology. Introduction, a new era in battery technology. As the demand for efficient, compact, and safe energy storage grows, solid-state batteries are emerging as a promising solution. Unlike conventional lithium-ion batteries that rely on liquid or gel electrolytes, solid-state batteries use a solid electrolyte, unlocking a host of benefits in performance, safety, and sustainability. What is a solid-state battery? A solid-state battery is a type of rechargeable battery that replaces the traditional liquid electrolyte with a solid one. This core difference transforms the battery's structure, improving its stability, energy density, and safety profile. These batteries are being hailed as the next big thing in both consumer electronics and electric vehicles. Solid electrolyte, the game changer. At the heart of solid-state technology is the solid electrolyte, typically made from ceramics, glass, or solid polymers. This component conducts lithium ions between the anode and cathode. Because it's non-flammable and more stable than liquid electrolytes, it drastically reduces the risk of fire or explosion. Higher energy density, more power, less space. Solid-state batteries boast significantly higher energy density compared to their lithium-ion counterparts. This means they can store more energy in the same volume. For industries like electric vehicles, EVs, this translates to longer driving ranges without increasing battery size or weight. Another standout feature of solid-state batteries is their extended cycle life. These batteries can endure many more charge and discharge cycles than traditional lithium-ion cells. This means fewer replacements over time, leading to long-term cost savings and reduced electronic waste. Improved safety, eliminating thermal runaway. One of the biggest concerns with lithium-ion batteries is safety, particularly the risk of thermal runaway and fire. Solid-state batteries address this directly. Their non-flammable solid electrolyte greatly reduces the likelihood of overheating or combustion, offering peace of mind, especially in high-demand applications. Operational efficiency, better in extreme conditions. Solid-state batteries perform more consistently across a wide range of temperatures. This makes them ideal for use in environments where temperature extremes can affect battery performance. From aerospace to deep-sea equipment, these batteries offer reliability that liquid-based cells often can't match. Environmental benefits, a smaller carbon footprint. Due to their longer lifespan and superior energy efficiency, solid-state batteries can reduce overall environmental impact. Over their operational life, they contribute less to emissions and waste. This makes them a more sustainable option in the transition to clean energy. Material requirements, less cobalt and graphite. Although solid-state batteries may use more lithium than traditional batteries, they often require less cobalt and graphite. These materials raise ethical and environmental concerns due to their mining practices. Reducing their usage can lead to a more responsible and cleaner supply chain. Applications in electric vehicles. The automotive industry is one of the biggest beneficiaries of solid-state battery technology. With higher energy density and improved safety, these batteries could revolutionize electric vehicles, offering greater range, faster charging, and longer battery life, all key concerns for consumers and manufacturers alike. Challenges to overcome. Despite their promise, solid-state batteries are still in the development phase for many commercial applications. Challenges such as high manufacturing costs, limited large-scale production, and interface stability between solid materials must be addressed before widespread adoption becomes feasible. Conclusion: powering the future. Solid-state batteries offer a compelling vision for the future of energy storage, combining safety, performance, and sustainability. As research progresses and commercial solutions mature, these batteries are poised to become a cornerstone technology in everything from smartphones to electric vehicles, reshaping the energy landscape for decades to come.